mate, welcome back, PlayBASIC coders. Just posted a small example before. I thought it was worth going over. So I've called this object echoes or object motion blur, and it's kind of an old effect. But we'll jump over to PlayBASIC. We'll run the effect first, and then we'll have a bit of a talk about how it's done. You can probably guess how it's done, actually, I would say. So we've got really a bunch of balls just bouncing around, a bunch of circles actually just bouncing around the screen. They're all just given random velocities, moving in whatever direction they want to move in, and each one has an echo or a blur kind of effect. There's a few ways of doing the same effect. You can have what's called video feedback, which is where each frame you draw the objects in their new positions and over the top of the previous frame, which has been dimmed down a little bit. That works really well for lots of objects. Generally, I prefer that method, but it does mean that you're never clearing the screen, and it can kind of get messy what you're looking at. This method here, what we're doing is we're drawing the object, and we're keeping track of where it was for the last 10 frames and going back and drawing 10 frames ago, 9 frames ago, and then with each time we step through there, we're drawing it with more intensity. So objects that are 10 frames old, they are still visible, but they have a much lower amount of blending. They're all blended with additive, so anything that overlaps will make it look sort of white or brighter than what it might actually be normally. Let's look at the code. In this section here, we have a declaration of our type. So each character on screen, we need its coordinates, and we need a way of storing where it was this frame, last frame, the frame before that, all the way up to 10 frames. So we're using two arrays here within the type. For its actual speed and direction, we're using just a pair of floating point fields called speed X and speed Y, and the color is just stored randomly inside the object as well, inside the character structure actually. So this is the fields that each object cares about, contains and uses, and we have our object array. I'll set it to 35. You can just change the size if you want, let's just try it with 5 for example. A bit easier to see what's going on with 5 characters on screen. Hit space to exit. So before the program starts, when it's running, it's not actually creating any new objects like you would in a game. So here I've just run through and filled up our objects array with some randomized data. So each object's created it's given a randomized position. So here I'm looping through all of the available indexes within this objects array, from 1 to however many objects are in this array, allocating a type structure, the T object type for this position within the array, coming up with a random space that's on screen, setting all the positions of this object, so its current position, its previous, etc. all start off at that same location when we start, which means that they're all being rendered over the top of each other. We randomly compute a speed and an angle, so we can come up with a vector for its current direction. We're just using constant sine for that. So the angle we're using polar coordinates and then computing the speed vector from that. The last one is our color, just using the random RGB function built into PlayBASIC to give us an RGB color. Now we could just do RGB. This is like shortcut for this. We could go RGB random 255, comma random 255, random 255. That's the equivalent. This does this. So save yourself a bit of typing and use the shorthand version. So that's set up our data. Beyond that is just the update of the screen. So if we put a break in here, run this in F7 mode, which is one of the debug modes. Just have to pull that across because the debugger's been moved to some other point for a different program. Go up to variables, select main, go through and click on the objects array. It will show us all of the 5 characters or the 5 objects in our object array and the contents of each one. So our X arrays are full of the same data, our Y arrays are full of the same data, and our speed have been assigned for this first object. Second object has different data because it was randomized. So it's handy. If you need to know what's in an array, it can be handy to use the debugger to check out what's going on in something. Sometimes you can pick up little inaccuracies in your own code where you might be looping too far, too few, that kind of stuff. Just by stopping the program and checking out what's in the debug view. Let's go back to the program, or remove the break statement. We don't need that. So this first section here is all just set up. This first page really is just set up. Nothing special. Then we're creating what's called an effects screen, which is really just a screen, an image that's stored in system memory, in normal system memory, not in GPU memory. And we're going to use that for rendering too all the time. So our main loop starts with a do loop. So at the bottom we actually have a loop statement down here, and we've added a statement after that, which is a conditional statement. So this is a conditional do loop. It acts basically like a repeat until. In fact, it's the same. So I could swap out the do and loop for a repeat until. It's the same thing, but it's just handy. Sometimes you might prefer to use the do loop syntax for that same thing. But all the basics tended to have a while loop and a repeat until for that kind of special thing. The nice thing about do loop in particular is you can put conditions on the start of the expression and at the end. One thing to remember. So that loop keeps our program running until we press the space key, and that will just fall through. And since there's no code beyond this, we hit an end statement, which is added at the end of every program that PB builds to exit execution. Let's have a look at the main loop. So the main loop is broken up into 2 things. We're going to move the characters first, and then we're going to render them. So that's what we're doing here. So we're running through every object. So I think we've got it set to 5 characters at the moment. We could change that anytime we like. We're grabbing the X and Y coordinate off the bottom of the array of the fields of the X coordinates and the Y coordinates for each object. Just to refresh our memories, up here we've used an array for our X's and an array for our Y's. So these have not just one value, they actually have a range of values up to that upper limit. And here we're going to consider the low value to be the current position, and then index 1 will be where it was last frame, index 2 will be where it was the frame before that, 3 is the frame before that. It's up to 10 frames ago. So its positions are held over time, over 10 frames. Once we grab its current position, we add speed. And I'm running through here, I'm copying its existing positions down 1. Its old current position becomes the previous frame and so forth. So they're all being copied down 1. This is for the X and Y for each object. Doing a quick clip to see have we hit the bounds of the screen. If we have, let's flip the speed on that axis. So if we hit the side of the screen, we'll flip the X-axis. If we hit the the top of the screen or the bottom will hit the y-axis. And we'll force it to be on the screen bounds as well, just in case we slip past something. And then we set its new position after it's moved, but we haven't drawn it yet. So we run through and we update the, what have we got, 5 characters? 5 characters at the moment. Once we've updated them all, we move on to rendering. So we redirect rendering to our effects screen. We clear the screen out. If we don't clear the screen, we just end up with eventually it's like painting itself over the screen. We'll have a look at that. As you can see, it's kind of a nice looking effect. I guess if you worked out a collection of balls, you could use that as like a transition effect, perhaps, you know. It's something a bit different. Let's reinsert the if you want to know what the 0 is here, RGB colors are stored in a 32-bit format. It's just a number, actually, just a 32-bit number. So if I insert here RGB, I want 0 red, I want 0 green, and 0 blue, which is what black is. That will give me a value of 0. Now I know that off the top of my head, but you may not. Now, if I recompile this, PlayBASIC will see this is a constant expression and it will solve it at compile time. So if you're more comfortable using RGB like that, then do that. If you're like me and you can remember a bunch of this stuff off the top of your head, then okay, whatever. Other weird ones too. If you want white, a quick way of getting white is just -1. And I'll let you work that out by yourself. Give you a hint. If you go and see what -1 in hexadecimal is, you'll see that it has all of the bits set, which would mean that the RGBs of values of those, the red channel would be 255, which is the upper limit. The green would be 255 and the blue would be 255. So that would give us our white. Pressing on. All right, so we're rendering to our screen. We're going to lock our buffer because we're going to be drawing a bunch of circles. We're going to change the pen drawing, which is, this one here is set to alpha edition. No, it's the color we select for the draw command. Not all things respond to alpha edition or this pen mode, but things like, you know, drawing a line, a dot, a box, a circle, they do. Things like text don't. It's not really supported. I guess it's possible if you did something like with serif fonts, and that has limited support for some things as well, because you can have blend modes with serif fonts, but it gets complicated because it's different. We're drawing using different methods and different APIs, and some things are possible and some things are not. Unfortunately, we can't do a blend of everything to everything, which is not possible. So we're setting the ink mode here. We're drawing to an effects screen. We know we can draw circles with this kind of effect applied, which is taking the pixels in the circle and we're adding them together to the pixels that are in the screen that we're rendering over. Then we loop through all the characters and we do 10 passes. We look at for each object we draw the object that was where this character was 10 frames ago, and we work out how much blend level we want for it. In other words, how bright this thing's going to be. So characters that are positions that have been rendered 10 frames old should be duller than the current one that's been rendered at its highest brightness, or its most luminous, I guess. So here we're just using a bit of a division and doing a clip to cut this range into 0 to 1. So we're starting from the oldest frame, from 10, and looping backward up to 0, up to the most current position. For the actual blending itself, we turn our blend level into basically a grayscale color. So we compute, we take our blend level, which is a value between 0 and 1, a floating point value, multiply it by 255, so it's a scalar. We invert it, we actually want the inversion of the colour, and then make a colour out of it using the RGB statement. We do this outside of the drawing loop, so we just compute that once, and we start drawing, so because all of the objects at this, during this pass will have the same blend level, that they'll all be not the same colour, but the amount of, they've faded this much over time. Then we head up and do a loop, and we draw the circles from this frame. We grab its position, we grab the object, and then we grab its position from this pass. So when pass is equal to 10, we're grabbing where it was 10 frames ago, computing its color with its level of brightness that it would need since it's 10 frames old, and then drawing a circle. We're just drawing the same basic 32 pixel circle. And that really is it. To recap, we do the movement first. We move them all first. Once they're all been moved and their coordinates have been stored in their own personal arrays of their current coordinates and their previous coordinates from previous frames, and we go through and we draw them back to front. So we draw the oldest, we draw it from where it was 10 frames ago, then we draw them all those at a low level of brightness, then we draw them the ones where it was 9 frames ago, then 8, then 7, etc. That's how you get the trails going behind it. Hope that makes some sense. Hope that's kind of useful for you. I'm not quite sure what people find useful. You know, if you've got some feedback about what kind of programming you want to see us doing, what kind of things you're interested in, how else you could use this kind of effect, I don't know. Hit us up in the comments below, or jump in the forum and just ask, you know. Until then, thanks for watching, and hope you enjoy programming, and just keep learning. Just stay at it. Keep going. Thanks so much, and see you. Bye.